Hey everybody, and welcome to How-To Videos with Dr. Amy Gates. This video is part of a massively open online video textbook for the Introduction to Statistics. To see all the other chapters and portions, or to check out anything else you want to know about math and statistics, check out mathandstatistics.com. So this video is going to focus on the central limit theorem, and it's going to give a full example and illustration of the central limit theorem using Excel. So here's what we're going to do in this video. We're going to use a very standard example, which is we're going to create a set of 1,000 values, so a data set of size 1,000, and that data set is going to contain what you would get if you rolled a single six-sided die over and over and over again. And we know that when we roll a single six-sided die over and over and over again, we expect to get a distribution of data that is called uniform, meaning that because each side of the die is equally likely to come up, after 1,000 rolls, we should have a very similar number of 1s and 2s and 3s and 4s, 5s and 6s. And that's called uniform distribution. And we're going to create a histogram in Excel using this data to prove that the distribution is in fact uniform. The next thing we're going to do is we will take random samples of size 30 from this large data set, and we'll calculate the average or the mean of each of these individual samples. Finally, we will graph the sample means. And what we're going to discover is that the histogram, or the shape, or the distribution of the sample means is in fact normally distributed, even though the original data set is uniform. And that's what the central limit theorem actually tells you. It tells you that no matter what your original data set distribution is, and in this case it's uniform, if you collect large samples repeatedly from that data set and you take the average of each of those individual samples and you graph all those averages, the distribution of the averages will be normally distributed. And that's pretty cool. So let's see what that looks like. I'm going to start from scratch and show you every single step. So one of the benefits of this video is you'll also get to learn how to do things like create random numbers in Excel, create histograms in Excel, and so on. So remember we said that our very first step was to create 1,000 data values that you would get if you rolled a die over and over again, and it's a six-sided die. So what this would look like is, let's say you roll the die, maybe you'll get a 4, then if you roll it again, maybe you'll get a 2, and if you roll it again, you'll get another 2, and you roll it again, you'll get a 6, and so on. But we want 1,000 of these values, and we want them to be randomly generated. So in order to do this, I'm going to use a formula in Excel called rand between. There's two ways to find formulas in Excel. The first one is if you happen to know the name, or you can even guess the name. If you click in any cell and you type equals, that equal tells Excel that you're going to start creating a formula. I know that my formula starts with an R, so if I type in an R, it starts to list for me every formula available in Excel that starts with an R, which is great, because if I don't remember exactly the name or exactly how to spell it, I've already found it. It's called rand between. And of course, if I keep typing in the formula, it'll keep reducing it down until I find what I'm looking for. Now rand between, and if I double click that, generates a random number between whatever two values I want. Well, I want numbers between 1 and 6, and it's inclusive. So I'm going to close the parenthesis and press enter, and then it generates for me a random value between 1 and 6. Now if I wasn't sure the name of the function, I could click down here and I could use the formulas option. This particular formula is in math and trig, so I click here, and then I can scroll down until I find the random number generators. Here's one of them, which generates a number between 0 and 1, and here's rand between, which generates a number between any two values. I can double click it, I can tell it what my bottom value is, which is 1, my top value, which is 6, and I can click OK, and it generates another random number between 1 and 6. And you might have noticed that when I clicked here, that top number changed. That's because every time I do anything in Excel, it's going to keep randomly generating values between 1 and 6. And so once we've generated all of our values, I'm actually going to stabilize this, and I'll show you the little trick I use for that. I'm sure there's many different ways. So luckily, I do not have to create a formula for every one of these 1,000 times, because that would be terrible. What I'm going to do is click here. The formula is already here. I'm going to right click, copy that formula. Because that's actually a formula, not the number 3, when I do a copy here, I'm actually copying the formula. I'm then going to press my left mouse button down and drag. I want 1,000 of these values. So I'm going to drag very quickly until I get near 1,000. So we're very happy we don't have to do this by hand. We're getting close now, so I'm going to slow down. And here's 1,000. I'm going to release the mouse button and I'm going to press enter. Now Excel has generated 1,000 values for me randomly between 1 and 6. But I want to stabilize these, so here's my trick for doing it. Again, there's many ways to do this, but I'm going to click here on this column by clicking A. I'm going to press Control-C, which copies the whole column. I'm going to open up a notepad document, and I'm going to press Control-V. Then I'm going to press Control-A to grab everything, Control-C to copy it, and then I'm going to press Control-C in this area. And what that does is it highlights this again. Now I press Control-V to paste. And what that does is it goes ahead and it takes all of these values. I'll do it again. So Control-A, Control-C to copy. Highlight this, Control-V to paste. And sometimes it'll pop up and say, hey, your sizes aren't the same. You want to paste anyway? Yes, I do. Now when I click on these, instead of seeing a formula, I just see the number. Now, like I said, there's several ways to do this. To me, this is just the fastest way. But you can certainly use another method if you have it. This will stop Excel from constantly activating that RAND function. So now we have a data set of 1,000 random values between 1 and 6, just like you would get if you rolled a die. Our next step is to prove to ourselves that this data set of 1,000 values is in fact uniform. We're going to use a histogram to do that. To use a histogram in Excel, you want to click on Data. When you click on Data, you should look all the way to the right and you should see a Data Analysis option. If you do not see this, what you need to do is you need to download the Data Analysis Tool Pack. There is a how-to video for how to do that on my website, mathandstatistics.com. You can check that out and quickly download the Analysis Tool Pack. It's free. And once you have it and you restart Excel, you'll see this option. Once you have this option and you click it, histogram is one of the choices. And that's what we're going to use to graph these values. Now, I'm going to click OK and show you what the histogram requires. So, the histogram wants to know where's your data, that's the input range, but it also wants to know where are your bins. In other words, how do you want me to graph this? How do you want me to count this up? I don't have my bins created yet, so I'm actually not ready to build my histogram. So let's get rid of this and create the bins first. What are bins? Whenever you create a histogram or any kind of frequency table, what you have to first do is decide what are your categories. What do you want those histogram bars to contain? Well, I want them to contain the number of ones, the number of 2s, 3s, 4s, 5s, and 6s. These are my bins. I want Excel to count up all the numbers of ones that were rolled. I want it to count up all the 2s that were rolled and so on, because what I want to see is the frequency of each of these values as a histogram. And I'm expecting that the frequency of each of these values is actually going to be very similar. And that's why this is a uniform distribution. So these are my individual bins. Now I'm ready to click Data Analysis, Histogram, and OK. Because now I can tell Excel where my data is and where the bins are. First, where's the data? I'm going to click here. Using my mouse, I'm going to encircle all the data. So I start with A1, I press the left mouse button, and I hold it down, and I just scroll very quickly until I get to 1,000. You can also type in the range once you get more familiar with Excel. Once I encircle all the data, I release the mouse button, and you can see that Excel knows now that my data is in A1 all the way to A1000. And that's exactly where it is. Now I want to tell it where my bins are. So I'll click here. I'll scroll back up because it's all the way down there at 1000 now. It's going to scroll back up here. And I want to highlight my bins. The definition of my bins is in C2 all the way to C7. You can put your bin ranges anywhere you want. It doesn't matter where you put them. You just have to make sure you tell Excel where they are. Now I've got a couple other questions. Where do I want my output? Well, I want to keep my output here. So I'm going to click Output Range. I'm going to click in here, and I'm just going to click anywhere blank. So I'm saying to Excel, just wherever you need to put the output, start here. The next thing is I want Excel to build me a chart. And I'm going to go ahead and put the cumulative percentage on there so you can see that as well. And now I can click OK. And what this does is it tells me, here's all my bins. So I have 168 ones in my data set. I have 156 twos. I have 164 threes, and so on. This is the cumulative frequency. Of course, it adds to 100%. And here's the histogram. I'll make the histogram a little bit bigger so we can get a good look at it. I'm going to go ahead and delete this because we're not discussing this today. And instead, I want to make this a little larger. Here's all of my ones, my twos, my threes, my fours, all the way to sixes. I don't have anything in the more pile because I only had rows 1 through 6. Notice that essentially the number of each is the same. This is what a uniform histogram looks like. This is a uniform distribution rather than bell-shaped or skewed or bimodal. So far I've proved that if I roll a die 1,000 times, and it's a fair die and I do it randomly, then in the end I'm going to get essentially the same number of 1s through 6s, and I'm going to get a uniform distribution. And that's what I've shown so far. Well, that's great. But what the central limit theorem tells us is that now I can collect samples out of this giant collection of data. I can take the average of each of those samples, graph all the averages, and get a normally distributed set. So let's do that. Let's go ahead and get rid of this for now. I don't need it anymore. And I'm going to go ahead and get rid of this too. I'm going to delete this by moving all of these cells or columns over, doesn't matter. And now I'm going to take the next step, which is using this giant data set, I'm going to randomly collect samples of size 30 out of this data set. So how do you use Excel for sampling? This is another nice thing to know. I'm actually going to label these too so that I know what's going on. This is sample 1 that's going to come from a data set. I'll call this sample 2, sample 3, sample 4, sample 5. Now ideally, we would like to have as many of these samples as we can. Over 30 would be perfect. However, we don't have time for that. So I'm going to show you how this works and how we can build the histogram, and then you can make as many samples as you would like. So how do you build a sample? Let's click under sample 1, and again we're going to use data analysis, and if we scroll down a little bit we'll see that sampling is an option here. I'm going to click OK. So what does Excel want to know to create this sample? Well, it wants to know where's the whole data set. Well, I know my data set is from A1 to A1000. I'm just going to type that in. A1 all the way to colon A1000. That's where my data set is. My data set is not periodic. It doesn't repeat itself over and over. Instead, it's random. So I'm going to click the random button. This is a random data set. How many items do I want in each of my samples? I think I want sample sizes of 30. So I'm going to go ahead and type a 30 in there. Where do I want that first sample? I want it in a very specific spot. I want it right there. So I'm going to click here, and then I'm going to click there, because that's where I wanted to put the sample. I don't click labels because there's no labels on my data. Now I click OK. What Excel has done is it has generated from my data set a sample randomly collected of 30 values. And here it is. And so I can do this over and over and over again to get as many samples as I want. Sampling, okay, here's the range of my data, here's the size of my sample. Where do I want it? I want it there. Okay, that's another sample. And I can repeat this process again and again. And what's nice is the very last one you put in stays. So you only have to update where you want it located now, and it continues to create the samples for you. And I'm going to create a few more of these so we can have a few to work with. I want that one here. Here's my 5th sample. And I would like to put that one here. Again, my data range hasn't changed. The size of my sample hasn't changed. I'm just going to do this a couple more times, and then we'll create our histogram and see what happens. So I want here. Create 2 more. I want that one to start there. And our last one. And again, this works a lot better if you create maybe 30 or 40 of these, and there is a way to do them several at a time, but I really want to walk through this. And so now what we have is we have generated 8 random samples that were pulled from our sample of 1,000 rolls. Each of these 8 samples is actually only 30 in length. What I can do for each of these now is I can calculate the mean or the average of each individual sample. In Excel, the formula for mean is called average. It starts with an A. And as you spell out average, you'll see it right away. Double click it, and then tell it where the data is by encircling it with your mouse. Don't include the label. Press enter. So that's the average of my first sample. Now I want to do the same thing for all of these, so I'm going to right-click, copy, and I'm going to drag this formula across the bottom and press enter. But I want to double check that Excel did what I think that it did, because what I want it to do is I want the average of F2 to F31. So it did that. That's good. This one should be the average of G2 to G31, which it is. So it did exactly what I wanted it to do. You can already start to see that the averages are going to be near the center of this data, because the average of the original data set is 3, right? Because if you have a fair die and it goes from 1 to 6, the average is going to be 3. And so you can see that these averages are actually very close to 3 themselves. These are called your sample means. And the more samples you collect, the more sample means you'll have. If I graph these sample means with a histogram, and I don't really have enough to show you very well, but if I were to graph these sample means with a histogram, that histogram will start to look normally distributed. And again, I'm going to need many more of these for you to really see that. But let's work just with the ones that we have and see if we can at least get a peek at what this is going to look like. Now, what's interesting about this too is creating a histogram with this data is a little different, because this data is continuous data, whereas this was a discrete data. So I'm going to take each of these values and I'm going to create a little area over here where these values are. I'm going to round them too. So the first one is, and actually I'm going to let Excel round them for me. Home, let's make them a little smaller here so I don't have to type them all in. My first value is 3.57. My second value is 3.80. My third one is 3.77. These are all of my sample means. And again, as I noted, we really want to have many sample means so that we can better illustrate the central limit theorem. But this is fine to give an idea of how this would work and how sampling works. Now that I have all of my sample means here, I want to create a histogram. Remember that histograms require you to define the bins. This is not discrete data. So I have to decide, how do I want to build these bins? Well, I want to really see what's going on here. I know that my smallest possible value is 1, and my largest possible value when I roll the die is 6. But I know that my means, when I take the means of these data sets, they're actually continuous values. So I'm going to just go ahead and bin continuously from 0 to 6, because it's going to give me a really good look at what's going on here. It's going to count up and most of these will be blank because we don't have a lot of data, but it will count up all of the values that add up to each one of these ranges. So when you're binning continuous data, what you're actually doing is you're deciding what the ranges of those data can be. I'm going to explain that again in 1 second. And I know it can't be bigger than 6 or smaller than 0. So here's what I'm asking Excel to do. I'm saying count up the number of values that are 0. There won't be any. Count up the number of values that are up to or between 0 and 0.5. We know we don't have any. This one says count up the number of values that are above 0.5 and up to 1. And this one says count up the number of values that are above 1 and up to 1.5. So that's what binning for continuous data looks like. I don't need all these bins, but I wanted to illustrate that. Now, once I have this, I can click anywhere blank, click Data, Data Analysis, choose Histogram, whoops, right there, click OK. And now I want to tell Excel where my data is. I don't have much because these are just the sample means. Let's get rid of that and circle my data. And now I want to tell Excel where my bins are. This is in the way, so I'm going to move it. And then I'm going to encircle my bins. And then I want to tell Excel where to put it. So I don't want it there. Let's just put it over here. Click OK. And so let's scroll over and see what it did. And what's really cool about this is even though we have so few data values, we can actually see that the distribution of the sample means is going to start being normally distributed. Let me move that out of the way so you can see it better. We don't have too many now, but as we start collecting sample means, most of them are going to be near the center and they're going to skew off to the sides. So even though our original sample of 1,000 roles was uniform, by collecting samples from that original collection and taking the means of the samples, the distribution of the sample means is actually normally distributed. That is what the central limit theorem tells us. So I hope this example was very useful in a number of ways, and thank you for joining me.